Welcome back. What we're going to do next is we're going to talk about types of data. When we see a number, that number means different things depending upon the sort of underlying principles behind that particular number. So that might not make any sense to you, but just bear with me. The first type of data of the four types is nominal. Nominal data basically comes from name. That's what nome means, right? Nome, Latin for name. This occurs, or this type of data basically is whenever we use a number to just be a sort of stand-in for a category. So it's a category. So let's say 1 is yes, and 0 equals no, right? Or sometimes you'll see them as 1 equals U.S. citizen, and 2 equals non-U.S. citizen. Okay? So nominal. This is considered sort of the lowest type of data, and there are some real restrictions on the kinds of things we can do with nominal data. But luckily, there are other types of data also. All right, the other type of data, or one of the other types of data, is ordinal data. Ordinal data comes from order, right? And this generally we can think of as order or rank. Okay? You can think of it as like finishes in a race. First, second, third. So you would get 1 if you finished first, 2 if you came in second, and 3 if you came in third. The critical thing to understand about rank data, or ordinal data, right, is that the distance between 1 and 2, and the distance between 2 and 3 is not uniform. So think of it as like marathon finishes. So let's say that this guy finishes in, let's say 50 minutes, and this guy finishes in 51 minutes, and he gets first, second, right? And this third guy finishes in 138 minutes, right? The distance between here to here is 1 minute, but from here to here is a whole lot more. So even though these numbers go 1, 2, 3, that doesn't necessarily mean that there's the same amount of spacing between them. And that's the critical sort of limitation of ordinal data. The third type of data is interval data. In interval data, right, the numbers have meaning, and there's a set sort of spacing, so a set or uniform distance between the numbers. So in other words, the distance between 1 to 2 and 2 to 3 and 3 to 4 is uniform. Right? And you can think of it as like degrees Fahrenheit, for instance, right? So in degrees Fahrenheit, right, the distance, if you're looking at it on a thermometer, right, the actual physical distance between these is all uniform, right? The critical thing about interval data, though, is that there is, switch colors, no true 0 point. So in degrees Fahrenheit, you can have negative 15, right? And if you looked at this on a thermometer, the negative 15 would be have equal spacing to negative 14 to negative 13, and so on and so on and so on, right? That negative creates a real sort of limitation that I'll get to on the next type of data. So in interval, again, there's a uniform distance between the numbers and no true 0 points. The final type of data is arguably the best data, called ratio data. In ratio data, right, there is a true 0 and there's uniform distance between the numbers. Okay? So there's a true 0 point, uniform distance between the numbers. biggest sort of example of this is degrees Kelvin. In degrees Kelvin, there's an absolute zero that you can't get below. So I'm going to find something in a second. This is the point at which molecules no longer move, right? So absolute zero. They're either moving a little, or they're not moving at all, or they're moving a whole lot. And degrees Kelvin is based off of that. So you have 0, 1, 2, 3, and so on. And there's uniform spacing between each of the points. In ratio data, because there is a true 0 point, you can do something that's really special. Hold on one second. Alright, so in a true 0, or when you have true 0 in ratio data, what you can do is you can draw what we call ratio judgments. What's a ratio judgment? Well, a ratio judgment is sort of what it sounds like. It has to do with 1/2 plus 1/2 equals 1. Okay? So these, right, halves are equal. They sort of add up to create 1. Each of these halves is a ratio. So you think of it like cups, like if you're baking or something, right? And the 1 here is equal to 2 halves. You can only actually do that with ratio data. It sounds silly, but it actually is very true, and it's very sort of important, okay? So with ratio data, you can say things like the group that scores 2 is equal to 1/2 of 4. You can only do that with ratio data, okay? And ratios, right, ratio essentially means fraction. Okay, a fraction, or you can think of it maybe as multiple. Okay. So that's the real sort of benefit of ratio data. Now this brings us to an interesting sort of point, which is what type of data do we have in psychology? In psychology, we tend to study things using scales and surveys. This is more of a research method thing, but sort of bear with me. In psychology, we tend to use scales and surveys, or maybe we ask, how happy are you? 1, 2, 3, 4. From 4 is very happy, right? And 1 is very unhappy. Okay? In this case, is there uniform spacing between the numbers, right? Is 2 here to 3, and 3 to 4, and 1 to 2, are these uniform in terms of units of happiness, right? Is that really an accurate way of thinking about this? Probably not, okay? So this is probably not interval or ratio. But we tend to actually treat it as if it is. In reality, we think that, as near as we can understand, when we ask a question like this, about how happy or unhappy you are using a scale, we think that this is actually an example of ordinal data. But we tend to treat it, anyway, as if it is interval. Okay? Alright, I will see you in the next video.